So to show that these two composites are equal to each other, the f of g of x and the g of f of x, they both have to, when we do our composition, our composite, they both have to equal x. So here's how it works. Let's do the f of g of x first. So let's put g into the f of x. So f of x is negative 2x. So negative 2, in place of the x, put in the negative 1/2 x minus 1. And don't forget your plus 1. Okay, we're going to start from the inside and work our way out. What are we going to do on the inside? Just, yeah. The negative 1/2, let's distribute that. So I'm still going to have that negative 2 on the outside. Now I'm going to distribute that negative 1/2 to the x, so that would be negative 1/2 x. And then the negative 1/2 to the negative 1. What would that do to it? Positive? Yeah, it's just going to change the sign. Okay, now, what can we do with the negative 2? Distribute it. Okay, so the negative 2 times the negative 1/2. 1. So it'll be 1x. And the negative 2 times the positive 1/2. Negative 1. And then we still have our plus 1 out here. Now, combine your like terms. What happens? Yeah. Did we get it? We did, didn't we? Because negative 1 plus 1 cancels out, and we get x. So look at that. It worked. It worked. So let's go the other way. Let's try it the other way. So let's... So the g is negative 1/2 times the quantity x minus 1. So replace the x with the negative 2x plus 1. And don't forget the minus 1. You see what's going to happen here? What's going to happen on inside the parentheses? What's going to happen to these guys? 1 and negative 1, they're out, right? So they cancel. So you have left a negative 1/2 times a negative 2x. What's a negative 1/2 times 2x? 1 what? 1x. And there you go. See how it works? Since both of these compositions ended up giving you x, everything kind of simplified out, these are actually inverse functions of each other. These are inverses of each other, which is kind of what we're leading up to. Okay? So composite functions, it is a way that we can check to see if we, in fact, maybe we found an inverse and we want to check and make sure we got it correct. This is one way that we can do it. One way that we can do it. All right, I just kind of want you to take a look. We kind of have two separate mappings here. We have a mapping of state to the population of the state over here, and we have a mapping of animals and their life expectancy. Okay? Take a second to kind of look at it, kind of compare and contrast. Similarities, differences. What's one difference that you see between these two mappings? What's a difference that you see? Okay, thank you. So over here, she's saying that all the states have a number that they are mapped to, right? Unlike what's happening over here. What's happening over here? We have the duck line and the pig. They're all sharing the 10 years. And we also actually have the dog and the cat that share the 11, right? So kind of little contrasts. Okay, so let's talk about what exactly a one-to-one function is. A function is one-to-one if any two different inputs in the domain correspond to two different outputs in the range. So let's take a look at our first. They kind of look like blobs, don't they? Let's take a look at this first one. Here's our domain, and here's our range. Do you think this is, given the definition, do you think this is a one-to-one function? Yes? Why? Why do you come to that conclusion?
Because both the X and the Y have their own pairs.
They're paired perfectly, right? One-to-one. Kind of like what it says, one-to-one. Very good. Okay? What about the second one? What about the second one? Would you consider this to be one-to-one, given your definition? Yes or no? Yes? No? No? Okay, so why would this one be a no?
Because X, Y, C share one.
So what's happening in this case is that two X's are being mapped only to one Y, or to the same Y. So in essence, what's happening here, this Y1 is being repeated, isn't it?
Yes.
Okay. When we were just working with functions, that was actually okay, right? Well, but a one-to-one function, it is not. So that one is not. Okay? And what about your last one? A function, a one-to-one or not? One-to-one? Mm-mm. Do you have something that's being mapped twice? Don't we have the x1 being mapped twice? We have an x that's being repeated. So can this be a one-to-one? No, this is also not a one-to-one. Okay? Because your x of 1 here is being mapped to two y's. So it's actually, in essence, being repeated. Okay? All right. What about this one? No, why? That 38 is taking on two x values, so it wouldn't work. What about your little set of ordered pairs down here?
It would. Yeah.
Yes, this one, if you look at all the x's and then you go back and look at all the y's, no repeaters, right? Okay. Okay. So here's an example of finding an inverse. We're just literally, right? We're just literally taking that switch and switching them, right? So now we have y, x, and we've made that switch. Okay? When we do that, remember that when you switch your x and y, what else gets switched as well? If you switch x and y, your inverse also gets, what else gets switched? The domain and range, right? So also remember that your domain and range gets switched as well. Okay. So let's find the inverse of this set of ordered pairs. Okay. So negative 5, 1 would be what? Oops, that's not right. Okay. The 3, 3 would become what? The 0, 0 would become what?
0, 0.
Can't really see our switching on those, can we? Here we go. 2, negative 4.
Negative 4, 2.
I keep messing up on my parentheses and my... And the 7, negative 8.
Negative 7.
Right? So what now is the domain of the inverse? Yes. So what? Literally, what is it? 1, 3, 0, negative 4, negative 8. So the domain would be listed in order: negative 8, negative 4, 0, 3, 1. And what would the range of the inverse be? What's the range? Negative 5, 3, 0, 2, and 7. So negative 5, 3, 0, 2, and 7. So those also get switched. Any questions on that? I'm going to go ahead and stop there, and we're going to move over to the little handout that I passed out to you. We ran out of time. We'll do some more work on this. Okay, so now we're going to do the switch. So I'm going to put the x where the y is, and I'm going to put the y where the x was. So let's solve this for y. What would be the first thing you do? Subtract 7, so that would give us an x minus 7 equal to a negative 5y, and then what would we do? Divide by the negative 5. Remember, you divide into both terms over here. Okay, so those would cancel. So now we have found the inverse, our function inverse notation. The f, remember the f to the negative 1 of x. This is how we show we have found the inverse. And that is x minus 7 over, let's take that negative 5 and let's move that negative to the front. So we would have x minus 7, negative x minus 7 over 5. So do your switch. So put your x over here. Now you're going to have 2y squared plus 4. Now we're going to solve it for y. What's the first thing you're going to do to solve it for y? Subtract 4. So we would have x minus 4 equal to 2y squared. And then you're going to do what? Divide by 2 first. Okay, let's divide by 2. So now we have y squared equal to x minus 4 divided by 2. Okay, Adrian, now what? Now we do what? Now we take that square root, because the square and the root will cancel. Remember, when you take square roots, you can have either the positive or the negative, right? So let's rewrite with using our inverse function notation. That is the positive negative square root of x minus 4 divided by 2. Let's move over here to our graph. We have a 2x squared plus 4. What is your parent function?
X squared.
X squared. And what do we do to it? What's the transformation?
Move it up 4.
Moved it up 4. So 1, 2, 3. Moved it up 4, and then we did what? The 2x. That's a what? Vertical? Stretch. So we kind of stretched it. So let's just kind of sketch it in for now, since we're running out of time. Oh, that's not very lovely. So how then are we going to graph the inverse? So if we had time, what I would have had you do was graph in y1 the 2x squared plus 4. Now in your y2, if you have positive and negative square root, you have to enter it twice. So in your y2, you're going to enter the positive. So you're going to enter the square root of x minus 4. Make sure you put that in parentheses, divided by the 2. It's not letting me. That's a parenthesis, and that's a 2. And then in your y3, you're going to have to put the negative x minus 4 divided by 2. Again, make sure you put that in parentheses. Let's do that real quick.